Hello, everyone. Good morning. Welcome to our talk. Today, our talk title is Spark Uber Development Kit. I'm Kelvin, and this is my colleague, Gan. We are working at the Hadoop platform team at Uber. So our mission is we want to make transportation as reliable as running water everywhere for everyone. So something about our team, we are working at the Hadoop platform team. Our team is part of the data infrastructure organization at Uber. Our team work on a lot of services and systems for the Uber data infrastructure. Some of them, for example, we create and run the schema system at Uber. Also, our team help running the HDFS data lake. We also run a bunch of analytic engine on Hadoop. And Gan and I, we are in the Spark Compute team, and we are focusing on implementing framework and tooling for Spark application. So before we introduce the UDK, the Uber Development Kit, let's first talk about briefly our execution environment. First of all, we have a lot of Spark cluster. We have at least 4 Spark cluster, and their size are very different. The largest one is at least 20 times larger than the smallest one. And also, for different application logic reason, different team, different cluster, they use different resource allocation manager. Some cluster we use Yarn, and then some cluster we use Meso. And also, for the virtualization technology, some cluster we use Docker, and then some cluster we just use the simple solution, which is just the JVM. And for the file format, we also have a lot of different file format. The majority is Parquet file format. Most of our data are stored in Parquet, but we also have some data in ORC. We also have data which is encoded in the sequence file, and then we also have some just like plain text file in the compress format. And at the same time, Spark is one component in the whole production environment. We also have other open source technology like Hive, Presto, Kafka, Elasticsearch, and we also have a bunch of home-built service that we develop at Uber. And when people, they create and run their Spark job, they need to make sure that the Spark job can work seamlessly, transparently with the whole ecosystem. So just a very simple diagram to outline, from one angle, how our production system look like. For example, like we have a lot of data sources. Kafka is very popular at Uber. It is the major message bus dispatch system at Uber. And we also have a few key value store. We have our homegrown key value store solution. We also use Cassandra and HBase for some application. And we also have the traditional relational database like MySQL and PostgreSQL. But for all the data sources, we have a very complex and sophisticated ETL system. We transport all the data sources data into our HDFS data lake. Almost every pieces of Uber data, finally, they will be stored at our HDFS cluster. And then on the other side, we have a variety of compute engine for people to use to crunch the data. Obviously, people can use Spark to do complex data processing. And for some people, they prefer SQL, then they can use Presto and Hive. So we don't say that, hey, people, we only provide you one solution for this problem, so you have to use this one. No, we provide a variety of solutions for the user to choose so that they can, based on their problem and application logic, to choose the right tool for their problem. And also another key feature in our data system is we have schema for every pieces of data. So we can imagine that like in different data sources, we can have different topic of the data. Every piece of data they are mapped to at least to one and only one topic. And that topic has a schema. And the schema, we use Afro for the user to specify the schema. So anything like supported in Afro, like for example, letter schema, array, elem, they are all supported. And then we have different clients for the producer when they create the data, and before they send it to the HDFS, they will use our schema client to encode the data to make sure that the data does not violate the schema. And then all the schema are registered in our schema service. They are stored in our the schema storage. And then we have a system, we call it a watchtower. It is a UI for people to manage the schema. For example, people can first create a schema, and then later they can add more column or change the type. So watchtower is for the schema evolution management. So that means our system is pretty complex. We also enforce the user to use things like schema. So it turns out that on one hand, it is pretty powerful, right? Like we have schema. So it is very bad, it is very good for enforcing the data integrity. And also it is good for query optimization. But then on the other hand, it also makes it harder for the developer to create and run their Spark job. So we got a lot of feedback from the Spark user. They say that, hey, it is actually pretty hard for the beginner to create a first Spark job. Sometimes it is even hard for the experienced user too, because we have so many clusters, and also different clusters use different technology. At the same time, we require things like schema. And it is the motivation why we create a Uber Development Kit UDK. So the goal of the UDK is we want to abstract out the environment difference. Like people can use the UDK to easily create Spark job, and also transparently when they create and run the Spark job on one cluster, it is super easy for them to migrate and run it on the other cluster. And the second goal of the UDK is we want to make the whole Spark job creation and operation, the whole process self-service. Because our team is small, we don't have too much time to answer individual questions from the user. So we want to make the whole thing easy. They can help themselves by just using our tool. And also the other goal, the last goal is this is from the system angle, which is we want to help the user when they create a Spark job. We want to provide feature for them so that their Spark job will not create any harm to the infrastructure system. It is to make sure there will be some reliability guaranteed when they run their Spark job. So we can understand UDK by this diagram. So in our talk, we will put in different things of the UDK inside these 4 boxes. So on the vertical dimension, UDK consists of 2 major features. It is a collection of API. Programmer can call the API to do different things. It is also a collection of tools to help the programmer to create and maintain their Spark job. So I always like to imagine UDK is something like JDK, the Java Development Kit, right? JDK also has a bunch of API and tools. So it is something like this for the UDK. And then on the horizontal dimension, UDK has 2 target users. The first one is, of course, the engineers who they want to create and run their Spark job. And then the second class of the user we are targeting is the SRE. And SRE stands for Site Reliability Engineer. So they are our engineers at Uber. They are responsible for making sure that the cluster, the whole system, is up and running and stable. And for different users, the UDK has different goals, right? I go over the goals for engineers already, and then for the SRE, the UDK helps to prevent harms and make sure the system is reliable. Now, let me introduce in the following. Introduce 3 features in the UDK. It is a sample of our feature. The first one, we call it SC Builder. So SC Builder stands for Spark Context Builder. So if you have written some Spark job already, you know that the first thing you create a Spark job is to create a Spark context. So SC Builder helps you to create a Spark context. In terms of the object-oriented design, it is a builder pattern for you to create a Spark context. And the Spark context returned from the API has already abstract out the environment, meaning that no matter which cluster, which resource manager you are using, or which virtualization technology you are using, you just call the SC Builder API, and then the Spark context you got will have the correct and optimal configuration for your job to run on that cluster already. So it's just one call, super easy. And then when the engineer try to migrate from one cluster to the other cluster, they don't need to do anything, right? Because under the hood, the SC Builder will give them another Spark context, which is optimal for the new cluster. So why the user want to use it, right? They want to use it because the Spark context from the SC Builder, the configuration is already performance optimized. So in our experience, to run a Spark job optimally, efficiently, in terms of the performance, people have to at least set over 20 configuration. Spark is very compressed. In order to run the Spark job efficiently, there are a lot of configuration variable you need to tune. And for the beginner, it is usually very confusing and difficult for them. And the SC Builder abstract out all this detail. When the Spark context return, they have at least 20 configuration variable, which is optimized for the Uber environment and also optimized for individual cluster already. And also the SC Builder come with the debugging configuration. Let's say, unfortunately, the job has some problem, fail, and crash. People can easily debug the job. And also, we also put some SRE suggested, recommended configuration into the Spark context. For example, we enforce the serialization approach in the Spark context, so that we make sure that the Spark job running on our cluster, they are always using the best serialization format. And then the second feature, so the first feature, SC Builder, is about creation, right? And then this one, Kafka dispersal, is about at the end of the job, you got a bunch of results, right? And then remember that Spark is just one step of the whole process, just one component in the whole ecosystem, right? So usually when people they finish the computation, at the end, they want to send the job result to the downstream application for other application, for other purpose, business purpose, right? And Kafka dispersal, this API here, is trying to help for this purpose. So the RDD here is the first citizen, right? You run your Spark job, at the end, your result is in the RDD. And then you just call this API. And then this API will, in parallel, send your result to our Kafka cluster. And the good thing for the user is our API come with all the high availability feature. So the user, the engineer, they don't need to deal with the HA anymore. It is already in the API. And also we have feature for example, rate limiting. In the past, we have some accident that people create too many Spark executor. So there are too many concurrent connection going to the Kafka, and it caused some problem to the Kafka cluster. So with this API, under the hood, we enforce the rate limiting. So it is becomes much more difficult for people to cause any damage to the Kafka cluster. And also, like using this API, we enforce that like the RDD message come with the schema, right? Remember that like every pieces of data of Uber data come with the schema. So we also try to enforce this like in this API level. And Kafka is just one example. We also have other API doing similar stuff, sending the Spark drop result to system like, for example, Presto, Hive, and key value store. So the third feature, and this is not an API, this is a tool. We call it Spark Plug. The reason is because like Spark Plug for the car is to kickstart the car engine, and then the Spark Plug here is to kickstart your job creation. So it is mainly for the beginner. Like the beginner, their feedback is like it's very difficult to create their first Spark job, right? And then we talk to them and we find out that actually there's some like very popular pattern which cover maybe like 80% of the use case at Uber. So we collect those use cases and then create a set of template for the user. So the template do some very like common things like, okay, we've like create a Spark contest like at the beginning, and then next we try to get some data from the HDFS, do some computation, and then send it to somewhere, right? So most of the skeleton is already in the template, right? The user just need to fill in some blanks based on their application logic or based on their problem, right? And we have template, for example, to integrate with the Uzi so that the Uzi can schedule the job like regularly, and then at the beginning use some Spark SQL, get some data. We also have checkpoint API to do incremental, to help them to do incremental processing. And also we use the template to enforce like good engineering practice, for example, like unit tests, integration with the Jenkins. And people love it. They find it like very easy to use. So just one example to see how the UDK help people to create Spark application. So this is one example of a Spark application at Uber, and it is pretty compressed. But even though it look pretty compressed, it is actually a very popular pattern at Uber. So we can see from here that we have a lot of different components, right? We have Kafka, we have HDFS, Hive, Query UI, Elasticsearch. We also have, so the red boxes, the two red boxes, they are the Spark job. You can see that they are just like one component in the whole ecosystem, right? So what the Spark job do is like they get some data from the HDFS. At the end, they send the result to the Kafka and also send it to the Hive. And then the second Spark job read the data from the Kafka, do something, again, at the end, push it back to the Kafka. And for those two Kafka topics, eventually they will be land to the Elasticsearch, and people can use it like either by Elasticsearch or by the Hive. Before UDK, people easily spend weeks to build this kind of application. And then after we created UDK, we got a lot of report. People can just spend one day. They start doing it, they ping me in the morning, and then in the afternoon, in the evening, they told me it's done. It's running in production already. And they can create things something like this. So this is the Elasticsearch UI. It is an open source like technology. And we just make it easy to, for example, send it to the Kafka. And then the Elasticsearch like ingest the data from the Kafka. And then just within a day, they can have like compressed like application like this. Cool, so I have gone over like 3 features. Now I'm going to pass it to my colleague, Gan. He's going to cover like 2 more features for us.
Thanks, Kevin. Hi, I'm Gan. Now let me introduce Geo Spatial Processing API in UDK. At Uber, we have tons of GPS logs and trip data. Many data scientists use Spark to do geospatial processing, and most of them are based on SQL queries. So UDK provides a bunch of UDFs to facilitate their processing. UDFs here means user-defined functions. Let's see 2 examples. The within UDF in the left means that we want to find out whether an area contains a geometry object. And the contained UDF on the right is a reverse version. You can use this UDF to find out whether a car is inside a city, or you can find out all the cars inside that city. These are two other examples. And the overlap UDF means that you want to find out whether two geometry objects have overlapping area. You can use this UDF to find out if two trips are similar or not. Also, the intersect UDF means that you want to find out whether two geometry objects have intersections. You can use this one to find out all the gas stations along a trip route. So you can use this UDF to build very interesting applications. Other than UDF, there is another common use case at Uber, which is spatial join. Spatial join means that you want to join two tables based on their geospatial relations. So for example, suppose the trip table does not have any city information. Now I want to associate all trips with their city IDs for a single day. Then I would like to write a query like this. I select trip ID from trip table and city ID from city table, and then join them on the contained UDF, which means that if the trip location is inside one city area, then I assign the city ID to that trip. And in the end, I restrict for 1 day data. It looks very simple, right? But actually, it takes 1 week to finish because of Uber's data scale. The problem is that in production, we use Spark 1.5, and it does not have broadcast join optimization for non-equality join. So actually, it is Cartesian join for the physical plan. You know, Cartesian join is very inefficient. So no matter how many executors you have set, there is only one used as the last stage. So it's not scalable. How can we deal with this problem? The solution is to build a UDF and broadcast it to every executor so that we can totally remove the spatial join. It takes 3 steps. The first one is to runtime build index. The reason that we want to build a runtime index is that many tables, like the city table, is very small, but they are constantly changing because Uber is expanding its business to new cities almost every week. So we cannot build a static UDF and use it all the time. So firstly, we build index, and we select city ID and city shapes from city table, and then store them into data structure like core tree or R tree, which is very fast for geospatial retrieval. This process is done at Spark driver side. The second step is to broadcast the geospatial index to executor. In UDK, we have many built-in UDFs which actually use those indexes. For example, we have getCityID UDF, which returns the city ID for GPS location. Then the last step is to rewrite the query. It totally removes the spatial join, and it takes 2 minutes only, which is far more faster than 1 week before. Actually, there are many spatial joins in production, so UDK improved their performance a lot. Kevin has talked about a tool called Spark Plug. Now let me introduce another tool, which is Spark Chamber. When I first tried to write Spark job, I was impressed by its powerful features. But when it came to debugging, I totally lost myself because there are tons of local log files across different machines. So if I want to find out the log file in one executor, I have to log into that machine. And then if I try to write a simple program to pass all the log files, then it turned out to be that it is out of capacity of one machine because the overall file size is very huge. And then if you want to find a specific log, then it's like find a needle in a haystack. And at Uber, we have many Spark beginners. It may take them a while to debug their Spark jobs. So we introduced Spark Chamber, which is a distributed log debugger for Spark. It's interactive. We extend Spark shell by hooks so that it's very easy for Spark users to adopt it. Now let me show a simple debugging session in Spark Chamber. This is the start screen of Spark Chamber. It just looks like a Spark shell, so what you need to do is to type in some commands, and then the result will show here. So by default, it automatically loads the most recent jobs of your own. It makes sense, right? Because in most cases, you want to debug most recent failed jobs. So here we have built-in commands like username and application ID to print out the information of current session. You can also change this information. If you don't know which application ID to debug, we have all application IDs command in the red boxes. So from the result, you can see the application names, and also they are sorted by time. Suppose now I have a failed job in mind, but I have no idea what's wrong with it. So I will set its job ID and then use the host command in the red box to print out all the executors. From the result, I can see the mapping between executor and hostname, so I can know more information about them. Here comes the most powerful features, which is first exception. In most cases, the first exception is the root cause of your failure. So if it happens in the driver side, it's very easy because you can find it out in the Spark history server web UI. But if it happens in executor side, it may take you a while to figure it out. So here I use this command to find out that it turns out to be an out-of-memory error happened in executor 4. Also, from the result, I can see the stack trace and also the host name and executor ID. So then I guess maybe it's something wrong with partition. So I enhanced my log and print out all the data count in each partition and use a search command in the red box to print them. So now from yellow box, I know that actually in the partition 3, the data count is very abnormal with far more than other partitions. So my guess is right. Other than the features I mentioned in the demo, there are other features like get all the exceptions, get all the messages from different types, and also you can display metrics information like CPU usage, memory usage, and disk I/O. Last but not least, you can also search whatever message you want, unless it exists. We also consider security, so we have supported 2 modes. Developers can only debug their own jobs. It's not a good idea for them to view others' jobs. But for SRE, they can monitor all the Spark jobs in the cluster, so they can know what's wrong in the cluster. OK, how does Spark Chamber find the log files? So in Yarn, we enabled Yarn log aggregation. In Mesos, it has a similar approach. Here, I take Yarn as an example. Yarn will aggregate all the log files into HDFS and then separate them by username and application ID. And then inside each application ID folder, the files are named after their host name, so it's very easy for Spark Chamber to pick them up. So how does Spark Chamber works? The basic idea is to use Spark to debug Spark. So we extend Spark shell by hooks, and then for one application ID, we distribute all log files to different executors so they can be processed in parallel. And inside each executor, it extracts log line and analyzes it. We can know whether it is an exception message or which executor it comes from, and then save them into data frame. Further, we will sort the log data frame by time and host name so we can give them a global order. By this global order, we can search them very quickly. Just like the first exception example in the demo, it is just exactly based on this global order. And last, we use a Spark SQL data frame API to find the logs because we can fully utilize the optimization in Spark SQL. Now, let me pass it back to Kevin for future work.
Thank you again. Thank you again. Cool. So we have gone over like 5 features in the UDK, and they are just some samples of the UDK. We don't have time to go over every feature. And next, in the future work, there's one thing like we want to do is to enhance the Spark Chamber. And in particular, we want to make it like very powerful for our SRE team. Some idea is like, for example, like for the SRE engineers, like they are more focusing on the whole cluster stability, right? The system-wide reliability. So we want to like inside the UDK to build in more log analytic feature. For example, like they can, hey, I want to know what is happening in the cluster for every job, no matter what team. Just give me some report, right? Or I want to focus one single team. It seems that like one single team is causing a lot of like using a lot of resource or causing like a lot of problems. So they can use Spark Chamber to just analyze the jobs of one team, right? And also we want to provide like analytic on like the time dimension, right? Let's like do the analysis like just focusing on last month or last week, right? And then another cool feature is sometimes like the problem only happen like on like the one rack, for example. It is like hardware, the topology specific. Like before we had incidents, like we found out that somehow like there's some straggler happening like randomly in the Spark job. We don't know why. Like somehow like some Spark job always has the straggler, and then when they happen, it seems random, and then like we do some analysis, and finally we find out that actually it is not random. All the straggler, they are all located on like run rack, right? So we want to provide this kind of like feature. And also now we have like all the log data, right, of the Spark job. We know their exception, we know their message, we know their metric like CPU usage, I/O, those kind of things. We can actually do some large-scale machine learning or data analysis. For example, like we can analyze like what is the resource usage pattern like of our cluster, right? Also the data access, like what data are being used more often than the others, right? Maybe we can like selectively replicate the hotspot data like into more copies, for example, right? And we can also do interesting machine learning things like, let's do some failure analysis, right? From the cluster level, what is the most common problem our Spark user always run into, right? If we know that, hey, somehow they always run into this problem, maybe we can provide some tools or even some API or more training for them to avoid this problem. We can also, based on the data, to see if there's any opportunity for performance optimization in the cluster level, right? So this is the things we want to build. And also, for other feature, like we also want to build some like API to make it even easier for the user to create Spark job. Like one popular ask from our users is like they want to send metric to our monitoring system. They want to know what is happening when the job is running, right? So they want to send metric constantly. So they ask for the API, and yes, we want to build this API for them. And also, we want to build more things like, okay, they use the, for sure they will use the data in the Spark job. Then how fresh is the data? Like when did the data get ingested into the HDFS? It is very important for their incremental processing so that they can have some SLA like for their application to tell their customer, hey, this data is up to date for the like last 30 minutes, for example. So this is all the thing we want to build in the future. And hopefully, like in the future, in other opportunity, Ken and I can share our update to the community. Thank you. I think this is the end of our talk, and I think we have 5 minutes for Q&A. Yeah. Yeah.
Question about Spark Chamber?
Yeah.
You mentioned the search feature that you have there. What does that search feature use a full text search?
So the question is like in the Spark Chamber for the search feature, is it we are going through the whole text search? And the answer is yes. We don't build indexing yet in our feature. So right now, what we did is like in the first pass, when Spark Chamber is up for a particular job, we cache the log in our memory. So that means like you have some delay in your first command, but then all the subsequent command, they are in memory operation. So yeah, so the answer is yes, there's no indexing. So we scan the thing like every time. Yeah. Any other question? Cool. Then I think, thank you for coming to the talk. Hopefully see you guys in the future. Thank you.